Welcome back to eMobility Trends. Today we're exploring the Pivotal Helix, one of the most realistic steps toward personal electric flight. This aircraft isn't a distant concept or futuristic animation. It's a real, all-electric, single-seat electric vertical takeoff and landing, that is, eVTOL, that people can actually purchase and fly. We'll look at how it performs, how far it can travel, how long it takes to charge, and what this technology could mean for the future of mobility. Let's get started. The Helix is Pivotal's production-ready electric vertical takeoff and landing aircraft designed primarily for personal use. In many cases, it qualifies under the FAA's Part 103 ultralight category, which means it can often be flown without a traditional pilot's license in the United States. That dramatically lowers the barrier to entry and opens the door for a wider audience to experience personal flight. The aircraft has a distinctive tandem wing layout with multiple fixed electric propellers and a sleek enclosed cockpit. One of its biggest advantages is mobility. It can be transported on a trailer and assembled on-site, eliminating the need for airport access or permanent hangar space. This flexibility allows owners to operate from private property or remote locations. The Helix represents a shift in aviation from something reserved for trained pilots to something far more accessible. Performance is where the Helix becomes especially interesting. It cruises at around 55 knots, or roughly 62 miles per hour, allowing it to cover short distances faster than driving, especially where roads are slow or terrain creates barriers. The maximum electric range is about 20 miles, supported by roughly 20 minutes of endurance. In realistic use, most flights will fall in the 20 to 25-minute window when takeoff, landing, and reserve energy are considered. Charging is relatively quick for an aircraft. Using a 240-volt charger, the Helix can fully recharge in about 75 minutes. Standard household charging is possible but requires several hours. This creates a practical cycle. Fly a short mission, land, recharge, and be ready to fly again without extended downtime. The performance profile makes the Helix suitable for short-hop travel rather than long-distance flights. Where the Helix becomes transformative is in how it reshapes mobility. Personal electric flight has often been discussed as a future idea, but the Helix brings it into the present. Owners could take off from prepared private locations, reach remote areas, or bypass congested roads entirely. It opens possibilities for accessing cabins, farms, islands, or work sites that are difficult or time-consuming to reach by land. Its limitations are clear. With about 20 miles of range, it is not intended for long trips or intercity transport. Instead, it excels at short, point-to-point missions where speed and terrain flexibility offer real benefits. Scaling this concept will require development of landing zones, charging access, maintenance networks, and airspace coordination. The relatively low noise footprint compared to helicopters may help with community acceptance, especially in suburban environments. From an engineering viewpoint, the Helix focuses on safety and ease of use. It features multiple redundant flight control systems and a ballistic parachute for emergency situations. Assisted takeoff and landing systems help reduce pilot workload, making the aircraft more approachable for new operators. Operationally, the Helix is optimized for short, frequent flights supported by its fast recharge cycle. The ability to transport it by trailer adds tactical flexibility, allowing deployment without reliance on airports. The starting price of around $190,000 places it in a premium category, appealing to enthusiasts, early adopters, and organizations that need rapid access to remote locations. Long-term use will depend on battery health, service support, maintenance availability, and software updates. Connected telemetry and analytics can help monitor performance and upkeep, but wider adoption will require strong infrastructure and reliable support networks. That wraps up our look at the Pivotal Helix. It may not replace cars or traditional aircraft, but it introduces a new mobility layer that bridges the gap between the ground and the sky. Personal electric flight is no longer just a vision. It's beginning to take shape. If you enjoyed this breakdown, make sure to subscribe to eMobility Trends and share your thoughts in the comments. Would you fly a personal eVTOL with a 20-mile range? Thanks for watching, and see you in the next video.